Back near the beginning of chapter 2, we saw this example where we were trying to look at the limit as x approaches 0 of sine x over x. And we used a table of functions, plugging in values that got progressively closer to 0, and from both sides, from the left and from the right. And we could see that these values get very, very close to 1. So we sort of guessed that that was the limit. Now, using something called the squeeze theorem, we'll be able to prove that that is the case. Okay, so let me get down here. In the previous video, you saw an introduction to the squeeze theorem, why it intuitively makes sense, right? So if g is stuck between two functions, and both of those functions are approaching this limit here, this value at a, then g of a, that limit, or the limit as x approaches a of g of x, should also be approaching the same value, right? Because it's stuck between those other two functions. So this is what we'll use to compute the limit as x goes to 0 of sine x over x. Okay, so here we go. So the first thing to look at in this picture, you might recognize the unit circle, right? So this height here is sine x. This one will be cosine x. Let me write that in. Or cosine theta in this case. One thing that you might not have seen before is that if we continue this triangle all the way up like this, then that length is going to be tan of theta, okay? Now this triangle is a similar triangle to this one. So how do we figure out that that's tan theta? Well, to scale cosine theta all the way up to 1, what we do is we're multiplying by a scale factor of 1 over cosine theta. And that looks like an x, but what I mean here is that we're multiplying by that scale factor. So multiplying by that. So then to get from sine theta to this height here, you multiply by the same scale factor. You multiply by 1 over cosine. And we know that sine theta over cosine theta is tan theta. Okay, so that's where that comes from. And why this is useful is because now we can more easily see that sine theta on this interval from theta being 0 up to pi over 2, right? That's this quadrant. Sine theta will be less than theta, which is just this distance here. Theta is the angle, but it's also the distance here along the unit circle. And then that is less than or equal to tangent. So it's kind of a geometric explanation that on this interval, sine theta is less than or equal to theta, which is less than or equal to tan theta. And now we can see how we're going to use the squeeze theorem. So dividing by sine in all of those parts, we get 1 less than theta over sine theta less than 1 over cosine theta, right? Because when we divide out by sine, tangent becomes 1 over cosine theta. And if we flip it all around, we need to flip the inequalities, we get this. And now remember, it's sine theta over theta is what we're interested in as theta approaches 0. Well, the limit as theta approaches 0 of 1 will just be 1. That doesn't change. And then for cosine theta, the limit as theta approaches 0 of cosine theta is also 1. So because sine theta over theta is stuck in between those, and they're both approaching 1 at that point, we can conclude that the limit as theta approaches 0 of sine theta over theta must also be 1. And that will be useful to us in later chapters, along with this limit, that the limit as theta approaches 0 of 1 minus cosine theta over theta is also 0.